Okay, so we're back in Desmos, and this time we're going to look at another type of graph, this time a cubic. The equation looks very similar, y equals x, but not to the power of 2. And remember, to get to the power, you go shift 6. We're going to do to the power of 3. And this is what a basic cubic looks like. Y equals x cubed is a cubic. It has a most important point as well, right here. Again, it's the origin. And in terms of this one, it's kind of like the middle of the wiggle, or the point of rotational symmetry. You could imagine taking this graph and rotating it around that point 180 degrees and you'd get the same graph back again. Well, if this is the basic equation for a cubic, can you also, like a parabola, move it up and down and left and right? Yes, you can, and it works exactly the same way. So at the end, we could add on a number and it lifts the most important point, that point of rotational symmetry, up 2, if I've added on a 2 there. If I take away a number, it drops it down. So there we go, I've dropped it down 3 places. And moving it left and right works just like a parabola. So I need to, with the x, wrap it up in brackets. And inside here, if I want to move it forwards, say 4, I'd need to take away 4. So moving it over here to positive 4, I have a take away 4 in my equation. Inside the brackets, it's opposite to what you think. Outside the brackets, moving it up and down, it makes sense. If I want to move it back, say to negative 2, well then I'd need to add on 2. There we go. And just like a parabola, we can do both moving up and down and moving left and right. So for example, if I wanted to move it 3 places to the right, I'd have to put minus 3. And if I want to move it up 2 places, well then I would need to add 2 at the end. And when I say it's moved, I mean its most important point, that point right there. The point of rotational symmetry, or the middle of the wiggle. It's been moved to the right 3 and up 2. And in the equation you can see that. The plus 2 moves it up 2. The minus 3 moves it to the right 3. Now, just like parabolas, you can also move this, you can also stretch this vertically. And just like parabolas, it's just after the equals sign. And if I put a number 2 there, I've made it sharper in the vertical direction. If I put a 3, a 5, a 6, it makes it even sharper still. I could put in a value which is less than 1, like 0.3, and it sort of flattens it out. 0.2 flattens it out more. I can put a negative number here, and that just inverts this graph, which flips it upside down, like that. So instead of going up and up and up across the page, this one goes down and down and down. What else can you do? Well, just like a parabola, you could also give it a domain. And the domain works exactly the same. On Desmos, you wrap it up in curly brackets. You need a starting value and an ending value. This one I'm going to start at 2, and then the domain is given with these less than or equal to symbols. So shift comma gives you less than, and equals, which is next to delete, gives you equals. Then x, then another less than or equal to. So I'm going to start at 2 and I'm going to go to 4. So here's the graph of a cubic that's been shifted to the right 3, lifted up 2, and it starts at x equals 2, and it continues until x equals 4. So that works very, very similar to parabolas. So if you understood it for parabolas, the only difference really is that the power for cubics is 3, whereas the power for parabolas is 2. Everything else works the same. Moving it up and down, moving it left and right, and the domain works the same as well. Hope this video was useful.